Hello and welcome to Adafruit Show and Tell. Good evening, everybody. This is the show where we catch up with all the folks in the community to find out what everybody's working on.
That's right.
We are
This
hanging
is
out.
the best place to show off all your awesome DIY, electronic, 3D printing, guide, like tours of your workshop, cool code that's being worked on. All that is game. You can join by going onto the Discord at discord.gg/Adafruit. You get an invite right there. Come on by. I don't have the Discord loaded, dang it.
It's fine. I got it on the side here. All right. So, yep, like you said, we're going to kick it off with some folks from Adafruit, and then we'll jump into community members. All right. Let's start off with Scott. Hello.
Hi, folks.
Hey.
I just realized I forgot to turn my lights on, but that's okay. So I've been working on USB host, which I showed last week, and I showed how it crashed. And I was working on it today, and I thought I had fixed it. So I was hoping to show that I had fixed it, but I'm not sure. So I'm hoping, there's this saying like the demo gods may cause something to not work. Well, I'm kind of hoping for the reverse. So why don't you pull up my screen there? So I've got the top is just like your normal CircuitPython connection. Your bottom is USB to serial output that has extra debugging data in it. So that's what you're seeing there. And what I did last week, and I'll try now, is I'm going to Control-C. And yeah, it didn't work. And we can see why. So we're getting a bunch of other stuff in here, and I'm not sure why. Device unplugged at address. Aborted transfer. I thought that would be enough to fix it, but apparently it's not. So I've continued working on this USB host support, and I obviously have more work to do. But I was trying to get it on Espressif and SAMD and other chips as well, and also running into some issues. So I think this is probably what I'll be doing on Deep Dive on Friday. So if you want to see Tiny USB debugging, stop by on Friday at 2 p.m. Pacific on these Adafruit streams.
Awesome. It sounds like this is the whole reason why you came on, just to plug the show, but definitely a good one.
Oh, yeah, of course.
No,
I didn't hope that it was just fixed and I could move on. Definitely not. It's called job security for me.
Definitely. Awesome. Yeah, everybody tune in. Should be an exciting one.
Cool. Thanks for having me.
Yep.
All right.
Some bugs.
Okay. Next up, we'll check in with Jeff Epler. Hello.
Good evening. I'm on a retro computing kick again. You're going to grab a board from down here. So a couple of years ago in an estate sale, I got some of this old computer called a Xerox 820.
Ooh.
And this little baby runs CP/M, has 64 megabytes of RAM and 64 kilobytes of RAM and 2.5 megahertz. And it comes built in. It's actually back here. I've got a bunch of these. There we go. Down there in that pile is like the thing with the built-in display. But I've got these other boards that don't have a display or a keyboard or a floppy drive, and I'm working on making them usable, by adding stuff to it. So what I'm trying to add right now is a display. And I had a thought of, well, I know from all the documentation that the display signal inside is digital, which just means it's like a 0 to 5 volts signal with horizontal and vertical information, and then whether the pixel is on or off, because it's just a green screen monitor. So I put together, and I'll risk giving some people vertigo here. I put together a feather with the DVI connector, and I've got it hooked up to my Xerox here. And now if you bring up my screen share, you'll see the fruits of that. And so this is a live view of what the computer is displaying, converted into a digital HDMI DVI signal using the Adafruit Feather DVI. And so here in the monitor on the software running in that board that's built in, I can disassemble. That didn't quite do what I meant, but it's showing like some of the contents of the memory. And yeah, so that is kind of one piece of what I want to do. Next up is converting, with some of Scott's code, a USB keyboard that it can plug into this archaic keyboard interface, which is a 25-pin thingy, a little bit like a printer, but kind of in reverse. So working on this, and eventually I'll be able to like spin up 3 of these classic computers, and I don't know, we'll play Zork on them or something. But that's what I'm up to.
It looks very crisp. I like the text.
Yeah, there are some numbers you have to fiddle to get it to be stable like this. If the numbers aren't quite right, it shifts like LCD monitors did back in the day when we plugged in our RGB and they weren't tuned just right. But yeah, this will probably morph into a guide in the Adafruit Learn system soon, because this is showing a way of using the Pico DVI. This won't directly apply to another system, of the age, but you can maybe adapt it to your own system. So I had a lot of fun making this. I was really excited to see it come together. This uses CircuitPython, which is crazy because, it's like 2 million pixels a second or something. But with CircuitPython, I made it work. And yeah, I'll do a guide sometime in the next couple weeks about it.
Cool. We're looking forward to it.
Okay. See y'all around.
Thanks.
And speaking of keyboards,
Yeah, let's check in with Anne.
hello. I think you got a project.
Yeah, my wife Amy, she gave me a nice gift not too long ago. It's one of these old time looking keyboards. They're made by a company called Datamancer, and they come in like wood and metal and stuff. They're very hefty, and you can see this one has a typewriter keyboard, which is better for me. The original had these keys that they're called Elizabethan, and I can read cursive, but this goes beyond that.
It looks like a hieroglyph almost.
Yeah, it almost does. I mean, some of these other ones are like,
Oh wow!
okay,
Yeah.
which orientation is that?
I think that's an A.
But they're all the standard Cherry MX.
Ah,
And actually, she also found, like on Amazon, you can get keycaps that are like the typewriter ones with Cherry MX
okay.
plus on them too. So I've got a bunch of keys that don't work very well, but I've got this cool keyboard, and now it plugs. It has compatibility with Mac and IBM, or sorry, PC. I might use that the USB host that is being shown and convert that to maybe use on one of these classic IBM machines somewhere. That would be kind of cool.
Yeah.
Maybe a USB to PS2, something like that. Although, those look kind of antique, but I mean, I think this looks a little bit more.
It looks so steampunk.
Yeah.
Especially with the brass. Is that brass? Do you
Yeah,
know?
it's brass.
Yeah.
This kind of keyboard was in Warehouse 13, and there's a similar one from the same company, Datamancer, was in Big Bang Theory.
Oh, okay.
I was gonna say that might show up on that Fallout TV series.
Could be.
Good.
Yeah.
I would not be surprised.
So does it come fully assembled or is it kit?
Yeah, it's fully assembled.
Okay.
But again, say you have your own preferred keycaps, they're just swappable. Actually, you can specify what kind of Cherry keys you want, and
That's
I'm
nice.
a Cherry Brown fan, Cherry MX Brown. So that gives me a pretty good, without having to really, bam, bam, bam.
I like the
something-
blue.
Yeah,
Super
like-
loud, clicky.
yeah. Well, I love clicky. I mean, my Corsair down here is clicky, but it doesn't require so much physical force that you're tired. Your fingers are tired at the end of the
This
day.
is true. I'm getting to where like I keep pressing the wrong freaking key, so I'd wish I like have to apply more pressure for it to actually accept. So
Well, I think Cherry has like a thing where you can get different ones and try them out. But I suggest you go to a computer shop that has different Cherry keyboards and try them.
pick your own.
Yeah.
Awesome.
Cool.
Look at that.
Well, thanks for sharing it. It looks lovely.
Thank you.
All right. Have a good night. Bye.
You too.
Okay. Next up, let's check in with JP. Oh,
Oh,
sorry.
no,
Yeah.
Hey,
it's the con we were talking about. We were like, everybody, all the Adafruit people should have access to the StreamYard. And we're like, no, we're all going to be clicking on the wrong
in,
thing.
out, in, out. Yeah, it's dangerous. Many operators. Hey guys, so I showed my first version of this watch winder last week on my live stream, and now I've refined it. And this is what it's looking like. So for background, for people who don't know what this is, this watch I have is a mechanical watch that does not have an actual crown winder. All it has is the automatic mechanism, which is essentially a eccentric weighted rotor, they call it, that spins around. You can actually kind of see it. It's hard to show because of the band, but you can kind of see it. Let's backwards, and I have hands in the way. Okay, you can sort of see there is
where the shine gets it.
pendulum. There, it moved.
Oh, nice.
There's sort of a pendulum-y thing in there, and that moves just by you wearing it, and it keeps it wound. It's got a little pinion mechanism, and it keeps it wound. So these are neat. These come in all variety of price ranges. This is an inexpensive one, it's a Seiko, but Rolexes and Omegas and Patek Philippe's is kind of a popular mechanism because it means you don't have to wind the thing. However, it also means that if you don't wear it for a couple of days, it's going to lose time and eventually just be wrong. So there's this whole segment of kind of weird watch connoisseur accessories that include watch winders, which look less Lego-like than this, but it's essentially the same idea. It's a little sort of compartment you put your watch into, and it spins sort of slowly to keep it wound. And then some of them will also reverse direction, and you can calculate based on your watch how much winding you want it to do so that it isn't just fully winding the mainspring all the time, but lets it actually run down a bit. So that's the idea behind it. And this is my refined version of it that I've got running on a Circle Playground Express and a Cricket board, which are now just driving one of our little TT motors, little gear motor here. I don't have it in here, but I had a pretty big gear train to step it down and give me some more torque. And then I realized that this little worm gear, which is just kind of two parts that is pretty common if you build any Lego Technic stuff, this gives me kind of what I need in a much smaller package. So we sell the TT motor and a little adapter that goes from the TT motor to the Lego axle. And then everything else in here is actual Lego. So I've got this little worm gear screw and a gear wheel, and that turns this bit here. And I also have it on sort of a little clutching peg, so it won't burn out the motor if it runs into something this can actually turn. So if I turn it on, oh, that's anticlimactic. Did I unplug you?
Oops.
Sure did. If I turn it on, it will
It goes.
spin it. I have it turning
Oh, cool.
out a revolution and then reversing just kind of for testing purposes. And I coded that in MakeCode, so it's pretty easy to go in and add features if you want to use the buttons to increase or decrease the speed, or change how many times it's going to spin before it reverses direction, how long to pause, all that stuff you can do pretty easily in MakeCode. Originally, I had done this with one of our stepper motors, thinking that I would need that for it to be kind of quiet enough to not drive you crazy, but this is actually not that loud, and you
Can't hear anything, yeah.
You could go ahead and encase it if you want to build a sort of a more elaborate thing around it. I 3D printed this cool Lego compatible Cricket plate that you guys built for some of our projects a few years ago. These are great. I have it on kind of obnoxiously tall standoffs. I might lower those. But the rest of it, you can see this is just popped into, that makes it compatible with Lego. So it's just kind of popped onto there. So I'm working on a guide for this. I just built this over in Lego or Bricklink Studio, which is kind of a popular CAD program for Lego stuff these days. So that will make it easy to share a build guide for that and a parts list for people who want to go buy the parts on Bricklink or on Lego Pick a Brick or something. And it'll be just like a page of MakeCode code explaining what it does, but otherwise should be a pretty straightforward build for anyone who happens to have this kind of watch or another need, because you can use these, you can kind of modify this for people like to make peanut butter turners that'll keep their peanut butter from separating, or just other stuff that needs to rotate. And then the small side, I tried to, and I may show this on the show tomorrow. Limor said, "Hey, what about trying to fake out a step counter on things like an Apple Watch or a Fitbit?" And so I tried we have the Bangle JS, which is an open source sort of smartwatch, and it has pedometer built into the firmware of it. It was not straightforward to fake the thing out. What I think they did was use real logged data of people walking to get an average of kind of what a pedometer like thing a watch look like. So it is not like some simple like spiking on one axis. So I'll show you tomorrow the ridiculous contraption I had that was basically doing like a oscillating pendulum motion with a wobble at the end. And finally I got the thing to fake out steps, but I don't know. I think maybe just wear it and walk.
Yeah, the Apple Watch Ultra, it gets tricked so easy.
Is that right?
I'm a broken record telling Noah that I hate this freaking thing. It's so dumb. Like I won't be walking and it thinks I'm walking, or I'm walking for like an hour, and it like when I get back home, it's like, "Would you like to start a run?" I'm like, "No, I just finished
one, and I want my hour back." You've ripped me off.
Apple is using this simple little freaking one, did the Z go get highlighted or go high here, because that's what it feels like when I'm trying to have the track my freaking.
I wonder if it'll get faked out just by rotation, because I know that some people, maybe if you look online, I think there are companies that are now forcing employees to get 10,000 steps to reduce their insurance, and so there's plenty of websites that are talking about hacks. A lot of them look like I suspect they don't work, but some of them are like, strap it to your fan and get 10,000 steps in 20 minutes, and then make sure you stop it or it'll be a little suspicious.
And here I am thinking it's like, it's looking at GPS and seeing how far you're going. It's like, nope.
Yeah, it could be, but apparently they're not.
No. Good use of the Lego wheels.
Yeah.
Oh yeah, thanks. Yeah, so that's kind of one of the issues with this, is that you need to be able to have sort of a wrist-sized thing that isn't too much of a pain to connect to. So I picked a fairly common sort of Mindstorm Technic kind of wheel that this fits on. And if you had a adjustable watch, this one isn't really easily adjustable. It'd be even better fit, but I'm also kind of squishing it into this piece here. So it holds pretty well. There are also, other orientations you could do it in, and probably different mechanisms you can come up with. But I tend to design this kind of stuff based on parts on hand, rather than like, what would be the ultimate solution of Lego parts? Instead, I was like, do I have that? Okay, let's try that, because then I don't have to wait for parts to come in. And I imagine you could probably do a pretty nice purpose-built 3D printed design for something like this, maybe just using some of the Lego parts for the gear where you want a lot of strength, but I'm sure
I think this is way funner to put together.
Fun to put together. That is true. Yeah, I love building with Technic parts, and so yeah. Right now, I think this is maybe
get one out for the kids.
I think this is maybe $30-ish in parts right now. When I checked against, like, that's one of the nice features in Studios. You can ask it, what's this model going to cost if I upload it? So it'll go based on average prices.
Very cool.
Nice.
All right. Well, that's what I got.
Yeah, all right. We'll tune in tomorrow. Yeah.
Thanks.
Super cool. All
right.
Thanks.
Bye.
Okay. And that is all the Adafruiters. That means it's time for Adafruit Community. We'll kick it off with Mark. Hello.
Hello. Hi. So about 4 years ago, I really got into electronics right as COVID hit, and it just happens to coincide with my birthday every year. So anyone that's been watching Show and Tell for a while has seen me made various attempts to put out a candle, some being more successful than others, including flooding my desk.
Oh no.
So last year, after I did one of my projects, Jeff Jepler suggested I should have one of those little candle snuffers. So this year, hopefully this all loaded, I have 3D printed a candle snuffer that hopefully, live demo worry aside, will put out the candle on the cupcake. fun, interesting fact, found out during this project that stepper motors do not have enough torque to even lift something this small without a gearbox. And well, you can 3D print gearboxes. I can't design and build one that works in a day. So the servo works great. It was from an old model plane. So with luck.
Oh, nice.
Well done.
I was gonna say I don't know how the angle is gonna work on it, but it's
It
dead
worked
on.
really well, yeah.
Yeah, there's a little bit of testing on it. But yeah, it worked perfectly, though it keeps just going
It
to
keeps
make
going,
sure
yeah.
candle is sufficiently out.
Wow.
But I am not flooding anything. I'm not lighting cardboard on fire or doing anything else that in the past has happened. So
Super cool. I
Excellent.
think-
Now, I'm hoping that's a real cupcake that you can eat now.
this is 100% a cupcake, which I will steal from there.
and now it's gone.
All right.
I
Well,
think the
happy
next
birthday.
step is do it as an IoT, right? Where just have like IO, push the button and over Wi-Fi do it.
Oh, it's always funner to actuate it yourself.
Yeah, I didn't have time to set
Damn.
everything up to go this. It was a fairly last minute project, but
It works.
I figured after getting the idea last year, I had to make sure I followed through.
Cool. Well,
Awesome.
everybody in Discord wish Mark a happy birthday. That was it's always great to have you on and kind of keep this as a tradition now. It's very fun.
It's been a fun way of picking a random thing that I haven't done before, whether it was motors, water pumps, and trying something new.
Yeah, very cool. All right, well, thank you for sharing that with us. It's
Thanks
it's
a lot.
very cool. All right,
Have a great day.
have a good one.
Thanks.
Bye. All righty, and now we're going to end it off with the fine folks at Nanographs. Hello, welcome.
Hello.
Hello.
Okay, so we're gonna screen share.
Okay.
So we've got the same sample in the microscope that Adam showed off last week, which is a MEMS accelerometer. And we, somewhat by accident, blew a hole in it after last week. So now we are just exploring the effects of high probe current on the sample.
Oh.
So electron beams are capable of milling,
Wow.
physically modifying the sample.
So,
It's not as clean as fib milling. It is a lot meltier, a lot more charged up.
Yeah, that looks melted.
yeah, so I guess we'll do some melting live. Do you want to zoom in a little
Oh.
bit, crank the probe current,
Yeah. Oh, how cool.
and compensate with contrast?
What?
Okay, really fully. So we, you can kind of see things. Yeah, there we go. Now we've got our kind of a melt
Coming
puddle
in.
forming.
Oh yeah.
Oh, wow.
So there's to the left is the lattice, the kind of waffly structure, and as we move that to the area where the beam is scanning, it just melts completely.
Oh, dang.
So this is with, so I actually did this on accident last time. I was trying to blast away a piece of dust that was on the sample. I was trying to charge it, make it fly away, and it moved a little bit, and it didn't move enough. And so I was like, okay, I'll turn the beam current up more. And I turned the beam current up more, and it didn't move at all. And then this is the aperture control right here. So we can move, if we can put a different physical sized aperture in the beam. And so I tried all 4 aperture sizes, and it didn't move enough. And then I removed the aperture completely. And when the aperture was removed completely, the sample just started disappearing in front of me, and I kind of freaked out and I zoomed out. And then I was like, actually, this is cool. So then I kept kind of doing it. So I'm going to put the aperture back in. So if we zoom out now, let's
Yeah.
drop the probe current first so we don't fry everything. So let's zoom out some. And we can go to probe current 11. We're at 16 right now. Yeah, so there's the area we just melted. So I'm going to put with the aperture out, this is about as sharp as we can get the picture. It's still kind of blurry. So I'm going to put the aperture in now. And go ahead and bring the contrast up. And we can focus a little bit more now. And we can actually increase probe current too. So we're able to get let's go to probe current 8. We're able to get a lot clearer picture now that we actually have an aperture in the column. But this is the power of an electron beam.
Very short. Very crispy.
You want to zoom out and show the whole chip?
Yeah.
So yeah, we
It's
and this thing is a couple of millimeters wide, so we are actually melting a pretty big area here with the beam.
So these electron, or the company that actually makes this microscope, Japanese Electron Optics Laboratory, they're coming out with an electron beam 3D printer. It kind of works like a laser metal 3D printer, except it melts the metal with the electron beam, and you're able to get really incredible material properties with that, like single crystal metals.
Whereas electron beams can be focused much smaller than lasers.
Yeah, so you're able to produce some pretty intricate parts that way with really good mechanical properties. And they kind of just like
You can weld with electron beams?
Yeah, you can do electron beam welding too. Electron beam evaporation. So the melting and the fusing, that's kind of at the higher end of what we're capable of getting out of the beam current of this particular microscope. But with some modifications, we could substantially increase the beam current by reducing resolution even more. And so it might even be possible to turn this thing into like a powder bed fusion 3D printer.
Oh, wow.
For very tiny parts. Because
cool.
the microscope that Joel, Japanese Electron Optics Laboratory, makes is just one of these columns, kind of like on top of a big chamber, and it's just a massive metal 3D printer. So, so yeah.
Amazing. Yeah, the welding part, that's what just blew my mind.
Yeah, electron beam welding. Electron beams are really good at just directly depositing heat. They they don't have the kind of
ions have a lot more mass than electrons, so ion beams have a lot more kinetic energy, so they physically like knock other molecules and atoms away. But electrons kind of
just heat the atoms up.
heat the atoms up without as much damage.
So with this we can evaporate stuff away, we can melt stuff, but we can't really just like slice as cleanly. With the focused ion beam that we had previously, that was using ions instead of electrons, and we were able to like slice with that. So there's more, and it actually kind of cools the sample as you hit it with the ion beam, because the heat gets carried away by the atoms that get like physically dislocated. But E-beam, it just all goes into heat. So.
Well, very cool. I
Yeah, do
didn't
you want to
expect
zoom
to
in on
see.
our little sandworm?
Oh, yeah, let's see. I know, that's what it looks like.
Yeah.
Nice.
Oh, man, PT would have got a kick out of
Oh,
this.
it's beautiful, yeah.
Like a dude sandworm.
Oh, wow.
Awesome.
Yeah, that's the spot
That's
where we
great.
just let the beam sit in the spot and melt.
Yeah.
Wow.
So yeah, that's the power of electron beams.
Very cool.
Thanks.
Thanks
Thanks
for
so much for
joining.
sharing and coming on tonight. We really appreciate
Yeah,
it.
absolutely. It's been great.
Cool. All right. Well, you folks have a good night.
Y'all have a good evening.
All right. Thanks. Bye, everybody.
Bye.
All right. Awesome.
Not expecting to see. Like,
Yeah. What a great way to end it.
Right?
All right. Well, this has been Adafruit Show and Tell. Thank you, everybody, for coming on. Don't go anywhere. In just a couple of minutes, Mr. and Mrs. Lady Ada will be streaming Ask an Engineer.
Yep, make sure to stay tuned into the Discord in case like some schedule changes happens. Be sure to find out there, and you can find all of the the script, the transcript for like the show, and all of the repostings of the live stuff will be up on the YouTube channel. So make sure to stay around for that. But I think that is it for this evening. Thanks to everybody for showing off your awesome projects. Forget everybody's shows tomorrow, and then all the other shows that happen throughout the week. Forget what the command is in the Discord. It'll tell you what schedule is there.
Cool.
But thanks for showing.
All right, folks. Have a good night. Bye, everybody.
Bye. Night.